Hello, everybody. So, this is me again, Rich Andre. And have you ever wondered why is the sky blue? Okay, we're going to answer that right in this video. Okay, you probably have already heard this topic in elementary or in high school or whatever class that you may be in, science. Okay, so I'm just going to give a little bit of a refresher. Okay, or for those who are new to this topic, sort of an introduction to what Rayleigh scattering is. So, what exactly is Rayleigh scattering? Okay, Rayleigh scattering. First, it helps us to understand how things work. Okay, you have a mirror. Let's say you have a mirror. Okay, and you're flashing a flashlight on it. What the mirror does to light is basically, okay, obviously, it reflects it. So the light bounces back from the mirror. This is called reflection. Okay? Now let's imagine a prism, okay? Let's imagine a different type of mirror, which we call a prism. A prism is sort of like a distorted kind of mirror. Well, not really distorted, but a triangular type of mirror. When you flash a light onto a prism, what happens is those light waves, they don't actually reflect, okay? They do reflect, but the way they reflect in this prism is entirely different from the way they reflect in the mirrors, okay? And what I mean by that is the lights basically they bounce all in different directions. You see? And eventually that light scatters, okay? That light scatters. The same mechanism can be applied to explain why the sky is blue, okay? So let's say you have a sun. Let's say you have the sun here, okay? And it's shining really brightly, okay? And let's say you're over here underneath the sun. When the sun shines its white light onto the earth, okay? Let's say you're in the when the sun shines its white light on the earth, the atmosphere of the earth basically interrupts with the white light, okay? So you can imagine the sun is shining its light, okay? But before it hits us, okay, before the light hits us, there is basically the atmosphere, okay? And I'm not going to dive deeper on what the atmosphere is, okay? So I'm just assuming that everybody knows what the atmosphere is already. So the atmosphere is basically scattering all this white light, okay? And that mechanism behaves exactly like a prism. The light that comes out of the sun is white light. It is white light. And if we try to deconstruct what white is, it's basically every single color out there. Okay, so we could say red, orange, yellow, green, blue, violet. Okay, so all of these colors they are made out of white, and when they scatter through the atmosphere of the earth, the color, the colors that make up white, they basically go on separate paths because they hit the air molecules. The molecules that are on the Earth's atmosphere are basically scattering the light as it passes through it. So You could imagine that this is the white light that the sun is emitting. When that white light hits a molecule, what scatters is different colors. And since light waves, okay, since light behaves exactly like ocean waves, okay, so you would imagine an ocean. You would imagine an ocean that is moving like this, okay? Light behaves exactly like waves. And there is a huge variation with the length of these waves, okay? Starting from red, we have the slowest kind of waves. And as it progresses through this order, okay? As it progresses through that order, it gets faster. The waves lengths basically get shorter and shorter. So you would imagine that, okay? They get shorter and shorter and shorter. Okay. Okay. Up to the point that it becomes like this. The waves become like this. Okay. So the big idea is the sky is blue because the light waves that are blue that is scattered throughout the atmosphere through air molecules. Okay. The reason why it's blue is because the blue light waves are very short, meaning they can scatter. They scatter more. Okay, they scatter more with the air molecules, and meaning, okay, the sky we perceive it is blue. That's what makes it blue. The blue light waves basically just scatter more than the other light waves. But there's a contradiction. How about violet light waves? They seem shorter than blue light waves. So naturally, you would think that the sky would be blue because of the premise that the violet light waves could scatter more than blue light waves. Well, there is an answer to that. You see, the human eye, okay, the human eye is basically more sensitive to blue, okay? Is more sensitive to blue light as opposed to violet. And that's exactly why the sky is blue. But what happens in horizons, okay? So you could imagine yourself in a mountain, okay? You could imagine yourself in a mountain. Right across that mountain is a body of water. Let's say an ocean. Okay? Well, you don't really need to be in the mountain, but I'm just going to use this as a reference, okay? You're on top of the mountain, okay? There's a body of ocean. When you see from your perspective, okay? When you see from your perspective, there is on the very farthest part of what you can perceive, you can actually see white light, okay? You can actually, the sky from the farthest point of the horizon, when you're in your perspective, from in this hypothetical situation, the light on the sky is actually white, actually becomes white. Why? Well, because as we've previously discussed, the sun, okay, it scatters. It scatters its white light. From this point, you can see blue light. But as soon as you zoom in with your eyes, farther and farther from this perspective, you can see that there is some white light right about here. And why? Because the surface of the Earth actually reflects and scatters the white light, okay, the blue light that the lights and all of the light waves that came from the scattered white light in the atmosphere, they bounce back and reflect and scatter back to the blue light that is currently being emitted from here. And once they scatter, okay, at some point they're all gonna combine, and that's exactly why some parts of the sky, okay, when you're staring at the farthest part of a horizon, it's white. Okay. But why exactly is the sky red or orange or yellow? Okay. Why is the sky red, orange, and yellow when it's sunset? Let me explain, okay? So when the sun is at the lowest point in the sky, okay? Usually because it's a sunset already. It travels through more of the Earth's atmosphere, okay? The light that the sun emits travels through more of the atmosphere as it tries to reach you. Okay? And that is the very cause. Okay? When the light travels through more of the atmosphere, it scatters more and more. Okay? It scatters more and more light waves. Okay? Meaning, okay? Meaning if there is more light waves, then obviously we're going to get more of these. Okay? And these light waves, regardless of how slow they are, will become more visible because the sun is actively scattering more light. Okay? It's scattering more light through the atmosphere. And that's exactly why the sky is red, orange, and yellow whenever it's sunset. Okay? So hopefully I have given you a good idea of what Rayleigh scattering is. Okay? So I'm just going to conclude this video by that. Okay? Thank you for listening. If you learned anything, please subscribe. And if you like the video, please give me a thumbs up. If you didn't like the video, please give me your honest feedback and I will comment back. Okay? And I will reply as soon as I can. Okay? Thank you for watching this video. Okay? Tune in on another video that I'll be posting soon.